Ladies and gentlemen, our final section of the course, section 11.4 on series and their notations. So start with a definition. A series is the sum of a sequence. So, for example, if your sequence is, say, 1, 2, 4, 8, 16, and so on, then the series is 1 plus 2 plus 4 plus 8 plus 16, and so on forever. Okay? Now, in the investigation of these series and their behavior, we talk about these things called the nth partial sums. So, definition. The nth partial sum of a series is the sum of the first n terms of the series. So, for example, in this series up here, S sub 1, the first partial sum, would be the sum of the first term. S sub 2 would be the sum of the first two terms. S sub 3 would be the sum of the first three terms, and so on. And so, recursively, you just add the next term with the sum of the previous terms to get the next partial sum. Now, notation. That we use. Summation notation. We write something like this. K runs from 1 to infinity of 2 to the k minus 1. This value of k is called the index. This 1 is the lower limit of the summation. The value up here is the upper limit of the summation. It could be a finite value or it could be infinite, as it is here. And this part right here, this is the formula. And the way this is read is we let the index start at the lower limit. The index starts at 1, and we get the term. So when k is 1, you get 2 to the k minus 1. 2 to the 1 minus 1 is 2 to the 0 is 1. And then this summation symbol, this is the capital Greek letter sigma. We use sigma as the Greek version of our letter S, standing for sum, means add the terms as they go through. Now when k is index increases to 2, 2 to the 2 minus 1 is 2 to the 1. When k increases to 3, 2 to the 3 minus 1 is 2 to the 2, and so on. And you regenerate the sequence that we're talking about up here. And it goes on till k reaches infinity, which means runs forever in this case. Now, there are formulas for the partial sums, depending on what kind of a sequence you're summing up. So if you're summing an arithmetic sequence, then the formula for the sum of the first n terms is n times the first term plus the nth term divided by 2. On the other hand, if a sub n is geometric, then the sum of the first n terms is going to be the first term times 1 minus that common ratio to the nth power, all divided by 1 minus r, and this is assuming r is not equal to 1, because then you would get division by 0. Alright, so those are our two formulas for this section. Now, let's take a look at some of the exercises and see what we can do once we understood this summation notation and such. So let's start with problem number 6, where we're asked in number 6 to express the description using summation notation. So we want to sum the expression m squared plus 3m from m equals 1 to m equals 5. Okay? Now, thinking in terms of this notation here, what they're telling us is sum from m equals 1, that's the lower limit, to m equals 5, that's the lower limit, and what we want to sum, the m squared plus 3m, that's the formula for what we want to sum. So now what we need to understand is how to incorporate this summation notation, and here's how we can do it. We sum with our index m running from 1 to 5 the formula. And it's that easy. Okay? That expresses this summation process. Okay? Let's try number 10. In number 10, we're asked to express this arithmetic sum using summation notation, and the arithmetic sum they give us is this. And so it's easy enough to see that this is an arithmetic sum with a common difference of 5, right? You're simply adding 5 every time. And so I want this to be the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th term added up. And so here's how I would write that sum. Okay? We write it with an index n running from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? And what we want to add up is every time, when n is 1, 5, n is 2, 10, we're adding up simply 5 times the index. And so there's your formula for how we would write this. In number 12, okay, the arithmetic sum we have is a half plus 1 plus 3 halves plus 2 plus ... up to 4. So it's easy enough to see the common difference. We're adding a half every time. Okay. The big question is, if I want to write this as summation notation, okay, what am I adding up? A half times n every time. But how many do I add up? Well, 1, 2, this is the third, this is the fourth, this is the nth, right? What is this supposed to be? Well, if the formula you're adding up is a half times n, then what would n have to be to get 4? N would have to be 8. And so there you figured that out. Okay. Number 14. We have in this arithmetic sequence 19 plus 25 plus 31 plus up to plus 73. And they say use the formula for the sum of the first n terms. Meaning, use this formula right here for the sum of the first n terms. So that means that the sum of the first n terms, n times a1 plus an divided by 2, is what we're using here. And I certainly know the a1, and I know the a sub n. And I know the 2. What I don't know is the n. So I have to figure out how many terms are here. So to do that, we have to think about it this way. Let's see. The common difference, I'm adding every time 6. The first term is 19. And so a sub n is a sub 1 plus the common difference times n minus 1 is our formula. That is 19 plus 6 times n minus 1. And I want to know, when is that equal to 73? Okay, so take your calculator to help you and say, okay, 73 minus 19 gives you 54, is 6 times n minus 1. Now divide both sides by 6. 9 is n minus 1, so n is 10. This is the 10th term, and there you can plug in 10. And once you have that, then you can do the 19 plus 73, multiply it by 10, and divide by 2. And you get the sum to be 460. Okay. All right, let's take a look at problem number 16 next. In 16, we have a geometric sequence given to us. 1 plus 3 plus 9 plus 27 plus 81 plus 243 plus 729 plus 2187. And so the common ratio is easy to see as 3. So first, second, third, fourth, fifth, sixth, seventh, and eighth term. And now I want to write this using summation notation. So from 1 to 8. And what does this form look like? Well, it's the first term times r to the n minus 1 power, right? So when n is 1, I multiply by none of the 3's, and I'm left with 1. When n is 2, I multiply by 2 minus 1, 1, 3. 1 times 3 gives me the 3, and so on. And so there's my formula written in summation notation for this. Okay. All right, take a look at number 20. Use the formula for the sum of the first n terms. Again, that's using this formula now for the geometric sequence. Okay, and 20. N runs from 1 to 9, 5 times 2 to the n minus 1. I put parentheses in there, optional. Okay, so when I look at this, the formula again I'm using, a1 times 1 minus r to the n over 1 minus r. When I look at this, r is 2. A sub 1, the very first term, when you put in 1 there, you get 2 to the 0 is 1 times 5 is 5. And I'm plugging that into my formula here. Of course, n is 9. Okay? So the a1, 5, 1 minus 2 to the 9, divided by 1 minus 2. And so let's see what we get when we work this out. Okay, 1 minus 2 raised to the 9th power is negative 511. I multiply that times 5. I get negative 2555, and when I divide that by a negative 1, I get 2555. There is the sum of that series, the first 9 terms. Okay. All right, let's take a look at number 22. In 22, we have 12 plus 18 plus 24 plus 30 plus and on and on. And we're asked, does this infinite series have a sum? Well, this is an arithmetic series. The common difference is 6, as you can easily see. So if you keep adding 6 forever, this gets infinitely large. And so no, it does not have a sum. Okay? All right, let's take a look at number 24. In 24, we're looking at m from 1 to infinity of 4 to the m minus 1. And we're asking, is this going to be something that has a finite sum, or does this not exist because it's infinite? Okay, well, this is a geometric, and r is 4. In order for the geometric series to have a finite value, r would have to be between negative 1 and 1. So that's not the case here. And that means no, this does not exist. All right, let's take a look at number 30. Find the indicated sum. A runs from 1 to 14. And we're summing A, so that means basically 1 plus 2 plus 3 up to 14. Well, that's an arithmetic sequence with a common difference of 1, isn't it? And so we know the formula for that arithmetic sequence sum is n times the first term plus the nth term divided by 2. So in this case, n is 14. A sub 1 is 1. A sub 14 is 14. 2. So you're getting here basically 14 times 15 divided by 2. or 7 times 15. So 105. Okay. All right. Let's take a look at problem number 32. In 32, we're given the sum from 1 to 17 of k squared. And we're asked to find that sum. Okay. Well, this is not an arithmetic sequence, and this is not a geometric sequence being summed up. This simply looks like 1 plus 4 plus 9 plus 16, on and on, until you get to 17 squared, which is 289. And those are what you're adding up. And we have no formula for this. So that means you have to use your calculator. Okay. Just keep adding the terms until you get to 289. Okay. So a very boring problem, and really only illustrates the fact that if you don't have a formula, you're out of luck. Okay. On number 34. Use the formula for the sum of the first nth terms of an arithmetic sequence to find the sum. Negative 1.7 plus negative 0.4 plus 0.9 plus 2.2 plus 3.5 plus 4.8. So it'd certainly be easy enough to just type those in your calculator and get the sum. But that would only serve as a check to make sure you're doing this correctly. The first n terms, 1, 2, 3, 4, 5, these are 6 terms being added up. Okay, so to use the formula, you would have to be showing the following process, that the sum of the first 6 terms is 6 times the first term plus the last term divided by 2. And that's what you'd have to do. You'd have to show that as your work. Okay? In 36, we're given negative 1 plus 3 plus 7 plus up to 31. Okay. And we're asked to find the sum of this. Well, that's the first, second, third. We'd need to know what term that is, right? And so the common difference here is 4. The first term is negative 1. And the formula a sub n is the a sub 1 plus d times n minus 1 is what we're using here, is negative 1 plus 4 times n minus 1, and we want to know when is that 31. So what is the n for this is what we're trying to find out. Add 1, divide, add 1. This is the 9th term. Okay, and so now I can use the sum for the arithmetic. S sub 9 is 9. Negative 1 plus 31 over 2. 9 times 15 is 135. All right, let's take a look at number 42. Okay, for the following exercise, find the sum of the infinite geometric series. 4 plus 2 plus 1 plus a half. Okay, so a sub 1 is 4, and the common ratio is a half. That common ratio is between negative 1 and 1, so that works. And that means that the infinite sum is a1 over 1 minus r. So that's 4 over 1 minus a half. 4 over a half is 8. There's your sum. And finally, number 44. We have, and I think the author messed up the writing of this. It's k from 1 to infinity, 3 times 1/4 to the k minus 1. Okay? So let's see what a sub 1 is. When k is 1, that's 1/4 to the 0 is 1 times 3, so a1 is 3. And the r, that's what you're raising the power to, 1/4. And so that's between negative 1 and 1. That means you can use this summation formula. So 3 divided by 1 minus a fourth, that's 3 divided by 3/4 is 4. And there's the sum. Okay? So that's it for section 11.4. Please do a good job on your homework and get ready for your exam.